Hi everyone, this is Soumyajit here. Welcome back to my channel. Today's video will be a mock interview that I conducted in the last week. I really hope that you are liking this series. If you want to know how to be part of this mock interview series, then watch this video completely. Because in this video, I will be telling you how you can be a part of this series. I will be uploading more such content as well as related videos soon. So please do subscribe to my channel and hit that notification bell so that you get notified whenever I drop those videos. I will be making a Q&A video soon. So if you have any question that you want to ask me, then please comment down below or message me in Instagram or LinkedIn. I will be taking each and every question that you guys have asked me and answering them in the next Q&A video. Without further ado, let's get started. Hi.
Hello. Hi, sir.
So as you had requested, we will do a problem solving data structures round for this one, and probably will go ahead and explain you the entire process of the mock interview. It will be a data structure problem solving mock interview, and first probably I will introduce myself, then I will ask you to introduce yourself, post which I will give you a problem. I will share a code share link with you, so you will be coding in that link itself. And while you are coding or while you are solving the problem, I will ask you to share your screen as well. So we will try and do it as similar as a actual interview will take place. So yes, let me just go ahead and introduce myself. I am Soumyajit Bhattacharyay. I'm currently working as an SDE at Amazon. I have recently joined Amazon in October itself, and yes, previous to Amazon, I was working as a senior software engineer in a firm known as Arcesium, which is a subsidiary of the Shaw. There as well as in Amazon, my day-to-day generally involves into designing solutions for product features or new systems that we are going to implement, and both high level and low level designs, and then ultimately depending upon the bandwidth of the entire team, implementing those solutions as well. That will be it from my side. You can go ahead and unmute yourself and introduce yourself.
Yeah. Hi, sir. I am Aditya, and I have done my graduation from Jammu Islamic University. I'm a 2020 plus graduate. I'm currently working at Geeks for Geeks as a member of technical staff in their content DSA team. My day-to-day work revolves around optimizing the reading platform of Geeks for Geeks. Generally, my work is to review the articles that are written by technical content writers, and I have to suggest some optimizations if there are any in the articles, and I have to restructure the code as well. My exposure to data success algorithms is good, and I'm doing computer programming since my third year, and I have solved 300 plus problems on lead code as well, and my exposure to development side is less as comparison to computer programming and data structure.
Probably I will share you the code share link. I have written some sample input. I have not yet written sample output, but let me just share you the code share link. I have shared it in the Zoom chat. You can go ahead and open it. And one more thing that can you do is please share your screen as well. So I will go ahead and I will explain you the problem at hand, and then we can discuss the solution and come up with an appropriate answer to that problem. The expectation is to come up with the algorithm right off the bat, and then we can go ahead and code the algorithm. Once we are done with it, then we can proceed further and ask any other question if required, or any pseudocode that I would like you to solve. So the problem here is we have you can see 1, 2, 3, 4, whatever you are seeing. Let's just say these are task IDs that are present with you, and the arrow shows the dependency of one task on the other task. So if I say 1 has a dependency on 2, it means until and unless 2 gets completed, 1 cannot get completed. So we have this task dependency given to us, and we need to print out whether or not all the tasks present here will get completed. That's the problem. If you have any questions around it, then you can ask me.
The problem says that the task 2 will get executed after the execution of task 1.
No, the problem says that one arrow 2 will mean 1 can only complete its execution once the task 2 gets completed. After that, only 1 can complete its execution. So 1 is completely dependent on task 2 to get completed. So consider these as separate functions, let's say. So 1 is a function 1, and it contains in itself function 2, calls to function 2. So until and unless the function 2 call gets completed, function 1 cannot get completed.
Like the task in the first column will get executed only after the completion of the tasks in the second column.
That's correct.
So we need to tell whether all the tasks will get completed or not. So, sir, I was thinking of approach like if we can take a hash map of of task ID and a vector, and that vector stores all those tasks which have a dependency on that particular task ID, which is in the hash key of the hash map. After storing all these ID and vector, or like all the tasks which we have a dependency on that particular task ID, we will, and after that we will iterate through the hash map and check, and like it's kind of a, like if we have created a graph of that all the nodes, and like it's like kind of a topological sorting, like we have several nodes and we need to visit all the nodes, and for a node to get completely visited, all its neighbors should be visited first. So it's kind of that kind of a problem, and we can solve this problem by using topological sorting.
Hi. Yes, the idea behind it is more or less correct. Now, probably, can you come up with an algorithm to solve this problem and code the solution? What all things are required here is that first and foremost, all the boundary cases should be covered. Like any kind of edge cases that can happen, it needs to be covered. Second, do not take any assumption into the type of data that is coming in. So keep that in mind, that the data coming in or the input coming in can be of different kinds as well. Whenever you are completing the code and writing the code, make sure that it's a production ready code, and there is no such basic obvious errors in them. And fourth, obviously, the problems will be solved.
I need to make an adjacency list from these given task IDs in order to apply topological sorting on them. Okay, so I'll take a vector adjacency which size is n, and I'll give this, and I'll create a function of adding the edges. It's kind of an undirected graph, no, sir?
No, it will be a directed graph, right? It actually depends upon how you view that problem and how you solve it. So it depends upon you how you are modeling that solution.
For topological sorting to work, the graph should be a directed acyclic graph.
That's correct. So as of now, what I can tell you is I will not go into the nitty-gritty of the implementation level details, but because that will be giving way too much of hints. But I would say is that the area in which you are probing, the DAG or directed acyclic graph, that area is correct. Now you have to think a bit on how you can use the properties of a graph in this current scenario and come up with a solution. And then after you are done with the implementation, we will go ahead and dry run it for some of the input outputs. Like one of this is already present here. I will probably add a few more inputs and see whether or not it's working fine.
So what I can do is, like, after storing or after creating the edges, after adding the edges, I'll check for the cycle. Check for the cycle in the graph.
Okay.
And so that it's a directed graph. I can make use of that 3-color approach to check for the cycle of the graph, whether it has cycle or not. And if it does not have a cycle or any package, then the task can be executed. Like, it's possible for us to do that.
Correct.
I'll use the 3-color approach, and it's like if the we'll take 0, 1, and 2 as 3 colors. If that node is 0, it means that node is not visited yet. Not the node, neither of it any neighbors. If it's 1, it means that that node is in processing state, right? If it is visited, and it's now the processing is upon its neighbors. It gets visited. And if we get the node as 2, it means that node and its neighbors are completely visited. Yeah. And if at any point I will, if I'll have the edge, and that is already completely visited, we can return from that one that the graph contains cycles.
So you can go ahead and implement the same. Okay, let's try run it once for this use case, and then we can see whether or not I will provide some different use cases as well.
First, we need to add the edges to a graph. Like, we need to create a graph from the given information. After that, what
one thing while dry running it, can you create the graph as well so that we can correlate it properly and see which value is going where and understand the entire algorithm properly? Like by creating the graph, I mean the adjacency list itself. Just create the adjacency list. That will happen after add edges gets completed. Okay, let's go through the function that you have implemented here.
So after that, I need to check whether the graph which we have created is having a cycle or not. Because if have a cycle or a self loop or like back edges, we can't get rid of them. Like we are revolving around those. We are not getting out of them, and we can't go on for the implementation of the further task. Like so, we need to first check for the cycle. And so I have implemented this function to check for the cycle in a directed graph. Like it's graph is having I made use of three colors. Zero, suppose we can say it's a white color, and one it's supposed it's a gray color, and two like it's a black color. And if the node is not visited yet, we will color that particular node with the white node. It means that node is not visited yet, and if the node's color is gray, it means that it's currently in processing, and its neighbors are not all the neighbors are not processed yet. It's the node is not finalized yet. It's under processing, and it's some of its neighbors is under processing. And yeah, it means like we have some recursive calls regard of this particular node's neighbors in the recursive stack, and it will get implemented. And the black color means that that node and all its neighbors are already visited. We have finished the processing of that node.
Okay.
So yes, I'll explain it earlier, and the working of this function. At any point, we will reach to that node which has already been visited or have completed its processing, and if we again reach that node, it directly makes sense that the graph is having node and it's kind of a loop. We again reach that node.
Makes sense. Can you go through it? Can you dry run this function as well, like the entire flow?
Okay. So I'll start with the 0th node and make a loop till nth node. If we need to call this function using a source node. So if any index or any particular node is not visited, I'll start the calling of the function using that particular node. So yes, I'll make use of like 0th node. If we have 0th node visited, or if it is present in the graph, we'll make use of that. Unless any source node or the first node which we'll send it to the function as a parameter, so that we need to start the function of that. Start calling the function. Like we have got, suppose the graph is suppose it is 1. We'll send 1. I'll make this 1 to n. So we have source node as 1. We will check if it is under processing. It's not. Its visited source value is 0. So after this point, we will make that node visited. Like 1 gets visited. And after that, I will check for the neighbors or the directed links where 1 will have a dependency upon. And for after that, for all the nodes, all its neighbor nodes, I'll check, and that recursion call started building up.
Yes. Can you build the call stack as well?
Yeah, I can try.
Yeah. So ideally, when you are explaining or dry running your code, what is expected is that you build the entire call stack as well if it's a recursive call, so that the interviewer can verify whether or not it is working correctly. And the other thing is the interviewer can verify whether or not you actually understand the solution and how your code flow works.
Okay. I'll try building it, but I'm having the intuition that I have done some mistakes in that particular function. I'm having the intuition.
Sure.
But yeah, I'll try building that. So we have two, because it's first number is 2. So that 2 is not listed. Okay, I will then go for 2's neighbor, that is 3. After that, 3's neighbor is 4. Go with 4. And after the 4th neighbor is 6. So that's 6. It's like as we reach 6th node, we don't have any directed node from 6 to any other node.
Correct.
So if at any point we don't have any neighbors, we'll simply return from that point of visiting that node.
Correct. That is correct. But where do you do that? The only caveat that I saw is you are checking for visited source is equals to 2, but you are not putting that anywhere. So visited source will never be equals to 2 because we are not equating it to 2 anyway. So if you add that, it will work.
I think after this particular loop and in the end of the function, I need to make that as completely visited.
Yes.
Okay. So after that, the sixth node is having a state of 2 and from it we will return true from that part. So sixth call gets out of the stack. That call finishes. After that 4, and I'll check for 4. Fourth node, that is 6, is visited, and now so we'll visit 4. We'll change the state of 4 to 2, like that node and its neighbors are already visited. So we'll make its state 2, and that call will again get out of stack. After that, okay, so after that 3, we'll come to 3. So 3's neighbor is 4, and 4 is having a state of 2. It means it's already visited, or it has finished its processing. So we'll make the state of 3 as 2, and after that we'll return from that point, and this call also gets out of the stack. After that we came to 2. So we have two neighbors of 2, that is 3 and 7. 3 is visited. It's like currently the state is 1, it's under processing, but 7 is not. So it will call upon the 7, and we'll go to the 7, and after that we will make that state 2, because 7 is not having any neighbor. So it's it will return from that point saying that I have completed my execution, and its state becomes 2, and it will get out of the stack. After that 2, and both the neighbors of 2 will also get visited, and it has completed its all execution. So that 2 state will change to 2 now, and after that it goes out of the stack. After that we have completed 2, we have completed 3, we have completed 7. So all the neighbors of node 1 has completed its processing. So we can make that state of the node 1 as 2, and after that it's get out of stack, and recursion call stack becomes empty.
Are you sure this will work and you don't see any flaws in the algorithm? This one was positive test case, right? That it is saying that the tasks can be executed. Let us run a negative test case as well, where there is a cycle, and let's see whether or not the algorithm works. So let us take a very basic example. 1 is dependent on 2, 2 is dependent on 3, and 3 is dependent on 1. Let's just test this one as well and see whether or not it is working. And then probably we can go ahead with some other testing.
I think I'm having the problem in this is cycle present function.
Yes. Why after 3, why will 1 be called?
No, sorry, because it's I'll check if it's not visited, only it gets called. Okay, I need to put another condition here. I can, else I will, if I don't have any node, I'll simply return true from that point. I think, yes. If I can't find any neighbor which I need to visit, I'll return true from that and make that node as completely visited node.
I don't think so that will work as well. Can you find out a test case where this will fail?
Okay.
Or let me just give you the test case where it will fail. So consider a scenario where 1 is dependent on 2, 2 is dependent on 3, 3 is dependent on let's say 5, and 4 is dependent on 5. 4 is dependent on 5.
1 is dependent on 2, 2 is on 3, 3 is on 5, 4 again is on 5.
Is on 5. And let's assume that we start from 4. So basically 5 will get completed, right? And then we take up.
I think I need to start from. Okay.
There are like several issues in the code. One is the way we are starting the cycle present. That is not correct because we are thinking that we will be starting from sequentially itself, starting from 1 and then going ahead. But it might so happen that 1 might be dependent on certain other nodes, and that will result in wrong decisions. Because 1 will get completed first, and then some other nodes who are depending on 1 will not get completed. So ideally, from where should we start? We should always start the processing from the nodes that does not have any in degree at all. Those will be the starting points. So that is missing. The second thing that is missing is once we add that, even if we start from like, even if we assume that that's present, you can probably go through the test case that I have given and see that if like four, if we start from four, five gets completed, and then we start from one, and one goes, two goes, three goes, and then three goes to five, which is completed, and it returns true that the cycle is present, but that's not the case. So your else condition is not right. That's it.
First, I will rectify this, like the starting node, that node which is having index 0.
That's fine. You can do that because that's pretty straightforward, and you can do that thing as well. In the else part where you are simply returning true, that will not be the case. It will only return true if the visited is one, right? We do not return true when the visited is two. Not there. Inside the for loop, there is an if, and then we are checking a cycle present, and if it's not that, then we are simply returning true, which is not the case. It should be basically else if the visited is one, then we return true, otherwise we return false. And
Okay.
and one more thing is after the execution of the loop gets completed, visited, we mark it as two, and then we are returning true, which should not be the case. Yes, this should take care of your basic cycle present algorithm, and it will work fine. And yes, that was pretty much it from the algorithm, yeah, from the question point of view. I have some feedback regarding this. Some positive feedbacks are that you were able to find or under catch on to the algorithm that is required to solve this problem. So that was a plus because you were able to understand what is the crux of the solution or what is the crux of the problem and come up with an appropriate solution. And upon diving a bit deep, you were able to actually identify whether or not you have to find out whether the cycle is present or not. So that was good, a plus point. On the other hand, although you were able to come up with the algorithm, there were some caveats in the implementation of that. So probably what I would say is once you come up with an algorithm, keep calm. And I sensed that you probably it was a graph-based question, and because of some time constraints or something, you rushed into solving the solution directly. So I would say that keep calm and think through the entire problem that is present at hand. Once you know that you have to find out whether or not a cycle is present, now think for like 5 minutes and visualize the entire flow, visualize the entire pseudocode. If you want to write the pseudocode, you can write the pseudocode. I would say just for 5 minutes, if you understand, if you have gotten the what algorithm you need to use, just think through the entire pseudocode, like what are the steps that are required here. Once you think through the pseudocode, you will start feeling confident on your implementation, and then you can start with the implementation. Once you complete the implementation, or that's very obvious that there will be certain things that you might miss while implementing it. There might be certain basic things that you might miss. What I would say is obviously run through the test case that the interviewer has given, but at the same time also try and think of different test cases to run your algorithm through. One of the best approaches is always, even while doing software development, what we do is we pass whatever algorithm, whatever design that we are writing, we pass it through positive test cases as well as negative test cases. Negative test cases are the test cases that are designed to fail that algorithm, and positive test cases are the test cases that are designed to pass that algorithm. So your algorithm should successfully complete in both the scenarios. So here there were two flavors of test cases, right? One, the cycle is actually present inside the graph. The second, the cycle is not present inside the graph. So I would suggest that you go through all the possible test case scenarios that you can think of, and while going through them, probably I would also tell you that ask you that you can involve the interviewer as well. So what will happen is interviewer will know or understand that yes, you are thinking about different ways to test your solution, which is a very plus point for an SD1 or for any SD for that matter, that you are actually thinking about how you will be testing your solution and what are the different test cases that you are considering, what are the different boundary conditions that you are considering. So if you show these things, then obviously it will leave a very good impression on the interviewer. Yeah, that will be pretty much about the feedback point of view. Probably I would suggest that practice graphs and trees a bit because I think so you are a bit rusty in implementing a graph or a tree from scratch in a particular in an interview setting, like in under 40-45 minutes. I am like 100% sure that you will be able to complete this algorithm given a normal setting. but probably I'm assuming that in an interview setting, like you are a bit rusty in implementing graph-based algorithms. So I would suggest that you practice those, because these are like common questions that might be asked, like graph-based and tree-based questions people generally ask. So I would suggest that just practice that little bit, implementing an adjacency list and doing a DFS, doing a BFS. Just practice those, so that sometimes what happens if you don't practice, it ultimately means that you have to recall certain little things, and that like that takes up a huge amount of time, and ultimately you are under time pressure. So that will not happen. So I would suggest that practice a bit of graph and trees as well. Yes, and that would be the feedback from my side.
Thank you guys for watching this much. I really appreciate your support and your feedback. Do comment down below how I can improve myself, how I can improve my videos, and what more different kind of videos you want me to make. I really hope that you are enjoying this series. If yes, then hit that like button and share this as much as possible so that it reaches maximum number of people. If you want to be a part of this mock interview series, then go and follow me in the Instagram account that I just set up and message me there saying that you want to be part of this mock interview series. That will be it for today, guys. This is Soumyajit bidding goodbye. Das Vidanya.